For completing the square, I'm going to do just one of these problems with you as an extra example. If you have any questions further than one more example, then you can just email me with a specific question. You need to make sure that for all four of these problems that you have the x terms isolated, which means they're on the same side of the equation by themselves. So number 27 is like ready to roll. Number 29, you are going to need to move the 8x over with the x squared by subtracting it from both sides, and now it's ready to roll. For number 31, you actually have to move the 25 over to the other side. So you have x squared plus 8x is equal to negative 25. And then same thing for number 32, you have to move the constant term to the other side to get your x terms alone. And then all of these are ready to go. And another good thing about all of these problems is that your coefficient in front of your x squared term is 1. So you don't have to divide it off. Okay, so I'm going to go ahead and continue the process. Our x terms are isolated on one side, the constant's over on the other side by himself. You need to add b over 2 squared to both sides, and my b value is negative 8. And I'm going to take negative 8 divided by 2 to get negative 4, and then I'm going to square that and I get 16. And that will be added to both sides of my equation. If you add the same number to both sides of your equation, you're still going to have your equation balanced. What you do to one side, you do to the other, and everything stays balanced. Left side is now going to be factorable, and it's going to be factorable in a very special way so that your factors, your binomial factors, they're going to be twins. We want factors of 16, positive 16, that adds negative 8. Well, negative 4 times negative 4 is positive 16 and adds to negative 8, and there you have it. Your binomial factors will be twins. So we're going to go ahead and write those binomial factors condensed. X minus 4 times x minus 4 can be written as x minus 4 squared. And then I probably should continue to clean up the right side. 16 take away 9 is going to be 7. And I'm going to bring that down, and then I'm going to go ahead and use the square root method now to clear off that 2. I'm going to square root that whole expression, x minus 4 squared. And it's going to clear that 2 off. What you do to one side, you do to the other. And notice I left a little gap here so that I can fit in my plus or minus. When you square root solving an equation, you're going to write plus and minus in front of your root symbol. And then on the left side, your exponent of 2 now gets cleared and the x minus 4 drops out. And then you get to finally add 4 to both sides. And you get x is equal to 4 plus or minus the square root of 7. And then you can just leave your answer like that if you want to. You can separate it into 2 answers if it makes you happy. One of your answers is x equals 4 plus root 7, and the other answer is x is equal to 4 minus root 7, but I actually prefer it condensed just like I have it right here. And then you need to make sure that your square root is like cleaned up. If this were, say, the square root of 12, then you would have to break that square root of 12 down further. If there was a negative underneath your radical symbol, you would need to take the negative out and turn it into an I. So not every problem just stops here. Sometimes there's a little more cleaning up that you would have to do with your square root symbol, but that is basically how you complete the square. Isolate your x's, add b over 2 squared to both sides, factor the left side into binomial twins, write the factors exponentially, square root both sides, and then add or subtract the number that's left with the x in the last step. All right, let's go ahead and do the quadratic formula on just one of these problems. I don't even know what looks good here. It doesn't really even matter. Eeny, meeny, miny, mo. Let's see. How about, I don't know, I'll do 37. So before you go ahead and start the quadratic formula, you are going to have to move everything to one side. So we have 5m squared plus 3m minus 2. If you don't do that, you're going to have one of your signs wrong when you're trying to plug in. Okay, so my a is equal to 5, and my b is equal to 3, and my c is equal to negative 2. And then we're going to go ahead and substitute into the quadratic formula. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we got negative 3 plus or minus the square root of 9. Then we have negative 4 times 5 times negative 2. A negative times a negative means that whole expression is going to be positive, and 4 times 5 is 20. 20 times 2 is 40. Oh, I think I picked an easy one. 2 times 5 underneath is 10, and the reason that I think it's easy is because I realized that when I add 9 to 40, you get 49, and that's a perfect square. So I get negative 3 plus or minus 7 all over 10. And now we're going to go ahead and split that up. I get negative 3 plus 7 all over 10, and I get negative 3 minus 7 all over 10. And then 7 minus 3 is going to give you 4, and you can reduce that to 2 over 5. And then over here you get negative 10 over 10, which is negative 1. And I know it took a lot of space up on this problem. Hopefully you can fit it in with a nice sharp pencil and not need to use as much space as I did. And then lastly, we have some graphing problems. Let's do, I'm just going to do 64 only because everything's already to one side and set equal to 0. And I just threw down my tablet and don't feel like picking it back up. So I'm going to punch in, oops, let's clear that out first just in case. I'm going to punch in 10x squared minus 23x plus 12. Now this is not a function, but I'm going to pretend it's a function. My graphing calculator doesn't know this is not a function. So I'm going to fake out my graphing calculator and solve it as though it was a function. All the zeros are going to be the actual solutions to this related equation. And you need to make sure that your equation is set equal to 0 before you plug into the calculator, and it already is. So, okay, so I'm going to hit graph. I'm pretty sure that I'm not going to really see my graph because my window was zoomed in. Oh, I do see some of it. My window was zoomed in from previous. I didn't think I was going to see it. So say you couldn't see it, you just go ahead and zoom standard, and hopefully you see your graph. My graphing calculator, this graphing calculator is not cooperating, so I'm going to start it over and I'm going to hit graph, and it better show up this time. There it is. And so let's just say you put in your equation and then you hit graph and you see this. That's kind of difficult to work with. That's kind of difficult to see. So I would zoom box, or I would zoom in and hit enter. I'll just zoom in like regular and hit enter, and there it is. And now that it's nice and close, I'm going to find those zeros. Remember, this is just an equation. It's not a real function, but my graphing calculator doesn't know that, so I'm going just to pretend that I'm working with a function, and I'm going to find those zeros. So I'm going to hit 0 and find my cursor. There he is. You can tell where your cursor is by looking at your x coordinate here. It says my x coordinate is at 0.6914, blah, blah, blah. That means it's, a little less than 1. And so if you're not sure where your cursor is, use this x value here to figure out how far left or right your cursor is on the graph. Okay, so my left bound, I'm going to set right there. My right bound's going to scoot to the other side of the x-axis, and I'm going to set that right bound right there. And then finally, our guess needs to be right on top, as close as you can get. That looks good. I'm going to guess it. And I get 0.80. And see if I can write with my trackpad here and not a pen tablet. There you go. So that would be my one answer, 0.8. And then I'm going to do second calc. I'm going to find the other 0. So I'm going to scoot this over, my cursor over a little bit. That's my left bound. Hit enter. Right bound is going to be above the x-axis. Hit enter. And then try to go right on top. Doesn't look like I'm going to get exactly on top, but as close as I can get. Hit enter. And then I have 1.5 as my other x value. And I'm using the trackpad, so this is even more of a challenge than a tablet. So x equals 1.5. Okay, and even though I have an equation and not a function, your graphing calculator doesn't know it. Just move everything to one side, set your equation equal to 0, and you can pretend that that was a function and you actually let the y equal 0 or the f of x equal 0 and plug it in your calculator and do it that way.